So we'll be going over 3.7, part of the lesson numbers 10 and 14. It says use the graph to find the roots of the cubic function. Okay, so we're looking at this thing and we need to find the roots. So if I zoom in enough, you'll be able to just like pick off the roots. As long as they're nice roots, you'd be able to pick them off. So the very first thing is, because this is a cubic, according to the fundamental theorem of algebra, I should be looking for 3 roots, okay? Because it's a cubic, that's the highest power of my polynomial, the 3. That means I should be looking for 3 roots. And you're like, Miss Johnson, there's only 2. Yes, but one of them is a double root. And I can tell that it's a double root because it goes up to the axis and then it drops right down. It like goes up, like taps the wall and comes right back, right? As opposed to this root right here, which it goes through the x-axis. So we haven't talked about a lot about double roots. We talked a little bit about it, but here's the breakdown of it. So because I'm looking for 3 of them, I actually only see physically 2 of them. But I notice this one is a double root because it kind of looks like a parabola at that root. Does that make sense? So here are my roots. My roots for this one is going to be -4, -4, and it looks like 1. That's what my roots look like. Okay, so I'm going to put -4, -4, and 1. And then how would I check this? Well, the way I check this to make sure that those are actually it and not just, my graph looking like it is, but it's not really, is if I plug this in for each of these. So I plug -4 in, I plug -4 in, and I plug 1 in. What should be my answer when I simplify that? What should be my answer every single time? And when I say plug it in, I mean Desmos. Yeah, it should be a 0. Very good. So the very first thing I'm going to do is I'm going to type in this equation x cubed. Oh, I don't actually want to do x cubed. I'm sorry. I want to do parentheses -4. Oh, man. What is this, Ms. Johnson? Okay, sorry. Parentheses -4 parentheses cubed plus 7 parentheses -4 squared, right? Plus 8 times -4 minus 16. I'm hoping it's 0. It is 0. Yay. So this guy's good. The other -4 is also good. And then I'm going to copy this equation. Let me see if I can copy. Yeah, I'm going to copy this and I want to type in 1. So I'm going to go 1, and you guys are thinking, oh, but Ms. Johnson, couldn't you have just graphed it? Yes, but I also want you to connect the idea that when I plug in a root, I should get out 0, implying that this is in fact an x-intercept, right? So done. It is perfect. Here are my roots of my function. What we worked on today also was, if I know the roots, I should also be able to factor this completely based on my roots. And so I'm going to leave that right there for you, which is actually number 11. So number 14, similar. It says, here's another cubic polynomial for your consideration. You'll notice it's given to you in factored form. Yay. Use the equation and the graph to find the roots of p of x. Now, again, because it's x times x squared, that's x to the cubed. That's x cubed. So I should be finding 3 answers. Now, some of these answers may not be real, like some of them will be imaginary, which if you look at my graph, I only see it crossing the x-axis once. Okay, so I wonder where those other roots are. So with that being said, let me just start solving this. So whenever they give it to me in factored form, I set it equal to 0. And I start solving it. So what would I do right here? What do I move to right now in order to move to the next thing? What would I do? What would I do next in order to find my roots? So I already know one of them is going to be -3, but what do I do with this guy? So here, what I would do is I would solve this. I would set each piece equal to 0 using the zero product property. Remember, 0 is your favorite times tables when you were younger. So I would just say x plus 3 equals to 0. X squared plus 4 equals to 0. Okay. So then I'm just going to solve it. This one makes sense because look, he's right there, -3. Yes, ma'am. X equals -3. Absolutely. But then I want to solve this. So how do I solve this for X? What would I do first? What would I do first? Good job. Someone says, hey, Ms. Johnson, subtract 4. Good job. X squared equals -4. And now you're like, oh, that's why we can't see the other roots. Because what happens next? What do we do next here? What do we do next? Yeah, actually we square root both sides. And then don't forget what? What does Ms. Johnson always say? Don't forget the what? Yeah, plus or minus. Woohoo. Okay, so the reason why we have to include plus or minus is because we came up with the idea to square root. So our answer is x is equal to plus or minus the square root of -4. Well, okay, so we need to work on complex numbers, or we need to review complex numbers a little bit. So remember that whenever you have a square root and it's negative, now we're dealing with i's, right? Like imaginary number I. So can you imagine taking out that negative? So it would look like this: x is equal to plus or minus I root 4. I'm just going to take out that negative. And when I take out that negative, the square root of -1 means I. Does that make sense? So here in my little thinking bubble, right? Square root of -1 equals to I, right? Okay. So then what happens is I need to simplify the square root of 4. And what is the square root of 4? Very good. It's 2. So our other roots are plus or minus 2i. So do you see that I have 1, 2, 3 roots? -3, 2i, and -2i. So we found all of our roots. Ms. Johnson, how did you know this was going to have 3 roots? Because x times x squared is x cubed. And the fundamental theorem of algebra basically says if you have a polynomial and it's x to the 3rd, then you should have 3 roots. Okay, so 1, 2, 3. Yeah, yeah. So you have 2 imaginary roots and 1 real root. Ms. Johnson, are you allowed to have that, like a mixed bag of roots? Yeah, you absolutely can have a mixed bag of roots. Does that make sense? Very good. So again, whenever you're doing these problems, the fundamental theorem of algebra will tell you, hey, don't forget, look for this many roots. So you're looking for 3 here. Let's look at this. Let's see if we have any more down here. Let's see. No. Oh, not really. That's just review. So again, using the fundamental theorem of algebra, you know that you should be looking for 3. So let's pretend that you forgot plus or minus. Let's just pretend you forgot. Ms. Johnson says to do plus or minus, you forgot. And then you're counting, because remember, this is only going to be 1. You're like, shoot, I only have 2 roots. I should have 3. Where's the other one? So the fundamental theorem of algebra is like your safety net, right? It'll teach you, it'll remind you, hey, don't forget you're looking for 3. Good job. Thanks for listening.